Lesson 5.2 is titled Relations and Functions. So make sure you title your paper 5.2, Relations and Functions. A key word is a relation. It is a set of ordered pairs. The age and height of ordered pairs below form a relation. So if I were to write this relation, I would write 18, comma, 4.25. That's an ordered pair. And it forms a relation, all of these ordered pairs together. So, first, what you're going to have to do is determine whether each relation is a function. So, they've given you, if you remember this from last year, we did it very briefly in pre-algebra. It was titled Using a Mapping Diagram. So, we would put all of the x values, and those are in the domain. So all of the x values go in the domain. And then you draw a line to the y value. So that's a -2, this is a -1, this is also a -2, and this is a 7. As long as there's no value in the domain that corresponds to more than 1 in the range, it is a function. So this is a function, because 11 just has one number, 12 has one number, 13 has one number, and 20 has one number that come off of it. If you look here, they did -2, -1, 6, and -2. If there is one number, like -2, that's listed twice in the x values, it is not a function. So this relation is not a function because you can't have something equal two totally different things. So, use a mapping diagram to determine whether each relation is a function. So push pause and try A and B. Okay, so I'm going to list my numbers. 3, 8, 9, 3, -4. And then I'm going to list my 3 goes to -2. So this is 0, no, -2. And then 0, 1, 2, and 3. So 8 goes to 1, 9 goes to 2, 3 goes to 3, and -4 goes to 0. And then 3 goes to 3. So if you look, you have two numbers that are the exact same in your domain. So this is not a function. Here, there is a 2, 5, trying to write them in order. 2, 5, 6, 6.5, and 7. And then my y values are -1, 0, 2, and 6. -1, 0, 2, and 6. So 2 goes to 6, 5 goes to -1, 6 goes to 2, 7 goes to -1, and 6.5 goes to 0. So if you look here, none of these numbers in the domain are represented twice. So this is a function. Another way you can tell whether a relation is a function is to use the vertical line test. If you remember this from last year, you graph your points. So you graph your 5 points, and then you take your pencil and you drag it across. If the pencil, like here, hits 2 points at the same time, it is not a function. So there's a couple different ways to do this. Now, recall from lesson 1.4 that a function rule is an equation that describes a function. So, what they want you to glean from this is that a function can have a different beginning. Okay, it's not always going to look like this, where it's y equals 3x plus 4. It might look like this. F of x equals 3x plus 4. These mean the exact same thing. They are the exact same. However, sometimes they like to say a function, this is function notation if you write this in your notes. when you use f of x to indicate the outputs. So it really means the function of x when you have x in for here. So you could also write it the function of t when 4 times t plus 5. So you could use any letter. It doesn't have to always be x. They just use function of x or f of x. So making a table from a function rule. So here, they have the function of n equals negative 2n squared plus 7. And then they want you to use 1, 2, 3, and 4 as domain. So you'd put 1, 2, 3, and 4 right here as the domain, and then you plug it in. So negative 2 times 1 squared is negative 2 plus 5 plus 7 is 5. And you fill out your table and you get your function. This is the output from the function. So try this. Make a table for y equals 8 minus 3x using 1, 2, 3, and 4 as domain values. So I'm going to make a table, x and y. Y is 1, 2, 3, and 4. And then I'm going to plug them in. So 8 minus 3 times 1. 8 minus 3 is 5. 8 minus 3 times 2. So 8 minus 6 is 2. 8 minus 3 times 3. 8 minus 9 is negative 1. And then 8 minus 3 times 4 is 8 minus 12, which is negative 4. So then I have my outputs here. These are my answers. Okay, so finding the range. So really what you just found were the range values or outputs. They really mean the same thing. So this one says evaluate the function rule f of a equals negative 3a plus 5 to find the range of the function for the domain negative 3, 1, and 4. So what they did is they solved each of these. Here's negative 3, here's 1, and here's 4. They solved it 3 different times and they found out my 3 answers. So then they said the function at negative 3 equals 14. The function at 1 is 2. And the function at 4 is negative 7. So let's do A. So f of x equals x minus 6. So I'm going to do x here, and then f of x in this column. So then I have negative 2, 0, and 5. So then what I do is I put negative 2 and I minus 6, so that equals negative 8. 0 minus 6 is negative 6. And 5 minus 6 is negative 1. So if I were to write this out, I could write it like this. The range is, and then you make a bracket, negative 8, negative 6, negative 1. Or they might want you to write this. Negative 8 equals the function at negative 2. Because I got that number from here. Is what did I put in to get negative 8? So, try B and C, and then we'll go over them. All right, so I have negative 2, 0, and 5 for x, and then my function of x, or y, is negative 4 times negative 2, which is 8, negative 4 times 0, which is 0, and negative 4 times 5, which is 20. So my answer is 8, 0, and 20. Here I have t and g of t. So t is negative 2, 0, and 5. So negative 2 squared plus 1 is negative 2 times negative 2 is 4, plus 1 is 5. 0 squared plus 1 is 1. And 5 squared is 25 plus 1 is 26. So my function here is 5, 1, and 26. All right, that's it for your notes.